The history goes back all the way back to 1956 when I arrived here as a result of an Army decision to send me down here to Redstone Arsenal to work on the Redstone and Jupiter missiles. At that time, those two projects were reaching their maximum effort, and the Army desperately needed people out of college to help them manage those programs or work those programs. I had graduated from Johns Hopkins University. I was in the ROTC, and as a result, I received my commission as a second lieutenant. And right after I graduated from basic training, they pulled me into Redstone to work on those two missile programs. I worked on those programs for 2 years, and I was released from the Army in 1958. And it so happened that right after I was available to work in the private industry, the development operations part of the Army that was out here at Redstone received the authority to start work on the Saturn I program. And the Saturn I manager talked me into staying here and working on this, what looked to be a very exciting and a new program. It was still within the Army, and because NASA was not established till 1960. Well, I worked on those two programs in the systems office, actually in the project manager's office, and was helping them define the overall development concept for the Saturn I and the basic definition of the program in terms of project requirements, overall systems requirements, doing that kind of staff work for the project manager. The Saturn I program was, at that time, of course, it was compared to what we're doing today, it was a very simple program because all Saturn I was, the objective of Saturn I were to take the existing hardware or existed Redstone tanks and the Jupiter tank and the Redstone engines and cluster them. It was the objective of that program was to clustering of engines, so that this country would be able to develop higher thrust launch vehicles. Most of the work had already been accomplished, the development work for the tanks and the engines and so forth. What they had to do was just do the overall systems work to put all those things together, cluster them together structurally, make some modifications to the control concept since we now had multiple engines. And all those things were new concepts, which, of course, made the program that much more interesting. So I worked on the Saturn I for a couple of years in the early stages, and they were starting to manufacture the hardware here at Marshall, and I performed some of the liaison between the management office, the engineering part of structures and mechanics laboratory, and the manufacturing people. In 1960, I decided to go after a master's degree, and I departed for 1 year on a sabbatical to Purdue University to receive my degree. And as it turned out, when I received my degree and came back, the organization had been changed from Army to NASA, and of all the things, the Saturn V concept was just being defined. While I was at Purdue, they were looking at the various, Von Braun and his team were looking at various concepts of higher thrust, larger capability boosters. They had the C1, they had the C2, C4, C5, and then C5 even had several versions to it. But they, about that time when I came back, they settled on the C5 version that actually became Saturn V, which had 5 large F1 engines on the first stage, and then the second stage they called the S2, and the third stage they called the S4B. When I came back, that program was just starting, and a project manager had been identified, and he had a small staff of just 3 or 4 people, and I ended up being probably the 5th or 6th person in that office. And the project manager used me to do basically systems type work again, similar to what I had done on the Saturn I, defining the project concept, the development concept of how many launches would be appropriate for this kind of a complex system, doing some of the system requirements work, defining the overall program requirements, and working with the laboratories here who were defining now the details of the Saturn V and the S1C stage. I did that work actually in the development part of the von Braun's team. Well, as the program grew, they established the Saturn Systems Office, responsible for both the Saturn I and Saturn V. And this small group that I was part of, the Saturn V group, was part of the Saturn Systems Office. The program grew to the point where it needed some reorganization and some additional staffing. They reorganized and brought in Dr. Art Rudolph, who was one of the famous people within the von Braun team, made him program manager, and of course he established a organization that had individuals responsible for the various parts of the program, like each of the stages. Then they also established a systems engineering office, and they appointed me head of the systems engineering. So we proceeded to now go into more detail on what it took to put this program together, and again, requirements, program development approach. The big issue, of course, in this complex program was to do the coordination between the various people that participated in the program, the various contractors. The contractors had already been brought on board during the first couple of years. And so we came up with a number of concepts to try to help expedite that kind of thing. Also, there were new ideas on how to manage large programs. Basically, they established something called configuration management, which really hadn't existed until that time. It was a much more less informal approach before, and configuration management made it a much more formal approach to making sure that everybody was on the same page. The Saturn V concept, as I've mentioned, was created here by the von Braun team. The S1C stage specifically was being designed in detail. Of course, contractors were being brought on board because of the size of the program. Like on the S1C stage, Boeing was contracted to help do the detailed design of the S1C, but the basic ideas and concept had already been put in place. Additional contractors were required to work the S2 stage and S4B stage, so the Marshall was also responsible for contracting for those activities. The idea of coordinating between all these different people, particularly as the program grew, required a systems contractor to pull all of these little pieces together and make sure the communication was working. The systems engineering office that I was involved in was responsible and interfaced with Boeing on that too. Of course, Boeing was helping us do all this kind of coordination. We came up with a concept of working groups where the Marshall people and the contractors met together regularly to coordinate each of the systems ideas and changes and so forth that were going on. So the working groups were a very important part of the overall activity. The Marshall people, of course, were very much involved with the contractors and also in defining the upper stages. A good example of that might be the S4B stage, which had a single engine, and the contractor did not want to go beyond a 6-degree freedom on the gimbaling of its engine, because it made the system a little bit more complicated. But the Marshall people insisted that it be 8 degrees, and it turned out that on I guess it was Apollo 6, the second Saturn V launch, that difference made a difference between a successful mission and a failure. So it was those kind of things that were going on all the time, and you can imagine with all of the participants in the program and so forth, it was quite a fascinating thing to see all these kind of things fall in place. The program had grown to such complexity that in 1965, NASA decided to change the whole organizational structure again of Saturn V, bringing in some very senior managers, some of them Army officers and generals, to take care of some of the management requirements that needed to be done for each one of the stages. So as a result, the Saturn V project office was changed, and General O'Connor, who was sent in here, was actually named they put in a level above the project called industrial operations, because of this massive amount of industrial work that was going on in order to pull this program together. So as a result of that reorganization, all kinds of other things happened, and as a result, I decided that, okay, I have accomplished, because all these people coming in, I decided I've about contributed as much as I can in this thing, and there was another program starting called the Saturn 1B Centaur, and I happened to be personally familiar with a personal friend of the manager of that program, so I decided to go on that project for a year. As a systems engineer, but the project only lasted a year, so from that I went on to Skylab. Engineering was not really identified as such until these complex systems started coming together. Obviously, we did engineering, we did systems engineering, but we never really called it that. We called it whatever else, coordination, this, whatever. But then systems engineering again put emphasis and focus on doing things that were important to bring large organizations, complex concepts and so forth together. Yeah, and that was pretty much invented in those early days. The thing is, it's such a, there are a lot of complex things going on today, but this is hardware, complex pieces of equipment like pumps and pressure bottles and all these other things that can fail on you, structures. Yeah, it's it was a challenge. The Apollo program and the Saturn V and the Apollo program, of course, saw an end coming after so many launches. We had landed the astronauts on the moon several times, and we knew that could not continue. But there was hardware available from the Apollo program that could be used to accomplish some different kind of missions. And of course, the Von Braun team had an organization within the group called Development Operations, and they conceived how this hardware could be used to establish the first space station called Skylab. So the Apollo applications utilized the command module and service module. It utilized the S4B stage. It utilized the facilities at the Cape and so forth. In a way, it was a relatively inexpensive program. but it did accomplish some new things, like including in it the Apollo telescope mount, which was a scientific mission that could be made part of that space station. So Marshall was assigned a job then of putting all that together, which we did with the contractors who were already on board, and ended up with a rather successful Skylab program. And then that went on. The Skylab program was the first space station, and by that time people in the aerospace community already thought, well, that Skylab was fine, but we really need a bigger space station. So that brought up the concept of the shuttle, because in order to build a bigger space station, one needed a transportation system up there that was able to refly rather than lose the boosters all the time. So the shuttle concept was brought up, and then the shuttle was developed, and the program went on to do the shuttle and then the space station, which we're quite familiar with now. Well, Ernst Uhlinger, of course, was a scientist, and he was interested in what kind of objectives the various missions should take on. The idea of Apollo applications was again that the Saturn V, well, the moon program came to an end. I mean, the nation kind of, after we landed the astronauts, kind of lost interest because of the excitement of the moon program all of a sudden was accomplished, and then we had to decide what else to do next. The other thing that was happening at the same time was a micro-miniaturization of electronics and a lot of other things that which made the payloads a lot lighter. So large launch vehicles were not required anymore at that point. And unless you wanted to go back to the moon, you wanted to go to Mars, and you could do your missions with smaller vehicles, which had been developed by the military or were being developed by private industry. The emphasis needed to go to something other than launch vehicles, and so Skylab, in a way, had also brought that change into the system, and we continued with that with the shuttle, because we knew the shuttle, okay, it was going to launch all these space station subparts up into space, but you could also put scientific instruments into the shuttle bay and do quite a bit of scientific investigation on the shuttle. Oh, there was, of course, after the moon landing and the end of the Saturn program, there was great concern at Marshall about what we might really do. And fortunately, we also had support from headquarters to do other types of missions. And that brought about well, of course, the Hubble telescope program, which was assigned to Marshall. And the Hubble telescope program occupied Marshall for a number of years and picked up where Saturn had left off. But after the Saturn program was over and Apollo program was over, Marshall, which had grown to about 7,200 employees, civil service employees, was downsized to about 3,000 or 3,500 people. So it was quite a shock to the organization. Of course, those were turbulent times, but the Saturn V program had the highest priority within the country of any program. In fact, when we went to suppliers of parts and materials and so forth, they were required to deliver to NASA before they delivered even to the military. That's how high the priority was. So that was one thing. Another thing is that people who were working on Saturn V were exempted from being pulled into any kind of military duty or being exempted from being pulled away from the Apollo program. And this was with all of NASA, not just Marshall. If you remember, Kennedy gave us this fantastic challenge of you go to the moon before the end of the decade. In other words, no later than 1969. And we had a humongous effort to pull together in order to pull that off. And because Kennedy had made that basically a national goal, the program had all the priorities as far as people were concerned, as far as the hardware were concerned, and there were no challenge to that from the Congress. If the program needed money, it was sent down here, period. No questions asked. The first Saturn launch, of course, was an extremely exciting thing because it's the first time that the agency and the Von Braun team had risked putting all the systems together and launching them all live at the very first attempt. So everybody was crossing their fingers that would be a successful mission, and it was. We had some problems on the second one. There were several failures, and that really increased the pressure tremendously because we were supposed to put the crew on the third mission, and here we had these serious problems. We had to solve those problems within 3 to 4 months because the next mission was scheduled with a crew on board, and we were able to accomplish that with some good engineering work, a lot of testing, and made the necessary changes and had a successful crew mission on the third launch. So that was important also, but the first launch really sticks you in mind, and the other one, of course, is Apollo 11, because now we were not just worrying about the launch vehicle, but we were worrying about the whole mission, with all this complexity in the capsule and lunar lander and so forth, and to live through that mission and see that crew land on the moon, of course, it's just a once-in-a-lifetime experience. And the thing that sticks out in my mind about Saturn V, the Apollo program, and the lunar landing is two things that come to mind. First of all, it was such a unbelievable accomplishment in its complexity and in its application that it has never been duplicated. That happened, 2 generations ago, and humanity has not been able to do anything like that again. And hopefully one of these days it will. But it is a goal or a challenge to humanity to do a more challenging and more interesting mission than that. It's just a unique thing that challenges humanity in my mind. So I think that's part of legacy. The other part is that because it was accomplished, and it was accomplished successfully, it tells me at least that given a clear goal, given all of the support that it needs, including the money, I think humanity can accomplish anything. I mean, any kind of mission. It's just a question of getting everybody together and getting the right kind of support.